Okay. Let's see here. Transformations is what we're talking about today. What is transformation? Transformation is a change in the position, size, or shape of a figure. The original figure is called a pre-image, and the resulting figure is called the image. I don't know why they chose pre-image and image. We could have said image and post-image, but we chose pre-image and image. Hate the player, hate the game. Okay, vocab words we need to talk about are pre-image and image. After writing, I'm going to talk about this. The pre-image will always have letters signifying the points. In this example, the pre-image has the points A, B, and C. After the transformation, the image has points that we call A prime, B prime, and C prime. Okay? So the pre-image, A, B, and C. After the transformation, A prime, B prime, C prime. The apostrophe, right? Y'all done English before, correct? The apostrophe, yep. Okay, good. The apostrophe signifies prime in here. A prime, B prime, C prime. Okay. We'll wait on Heather to finish. Oh. Woo! Here are the big 30. Okay, we're going to see these for a few days. They're going to be heavy on your quiz as well. Reflections, rotations, translation. Reflection or flip. It's a transformation across a line called the line of reflection. Each point and its image are the same distance from the line of reflection. So make sure in your notes, when you say reflection, you have the word written flip. A reflection is a flip. The trigger word associated with reflection is flip. So a hint, when your quiz is coming up this week, whenever you hear reflection, you should be flip. Reflection split. We can reflect across the y-axis or the x-axis. Okay? If we reflect across the y-axis, we go from left to right, right to left. If we reflect across the x-axis, we go from up, down, down, up. Top, bottom, bottom, up. Next, we have a rotation or turn. Okay, it is a transformation about a point P called the center of the rotation. Each point and its image are the same distance or equidistant from P. Trigger word associated with rotation is a turn. Rotations turn. Reflections do what? Flip. Reflection slip, rotation turn. A rotation curves, and I'll get into this in just a little bit. You think of them in terms of your quadrants, okay? You'll rotate 90 degrees, 180 degrees about the origin. You see that about the origin? The origin, 0, 0 is your point P. Okay? Right? We can pick different points. We could rotate from the center of 2, 2. Okay? They're all okay. Finally, the last one I've got for you is a translation. Translations slide. These are the easiest ones to typically recognize and the easiest ones to complete. They slide the same distance in the same direction. Okay? Check it out. If in this example, JNOK slides to the right and then up, or it slides up and then to the right. Correct? Right? No? Yes. Yeah. Okay. It slides right and then up. So, Lucas, reflections do what? Pretty good. Douglas, rotations do what? No. They do. But what else do they do? Good. Heather. Translations do what? You gotta slide. Okay? All right. Those are the three big transformations that we will be talking about this week. Okay? There's another transformation that we'll talk about later in the class called a dilation. But we save it for another day. Okay? All right. We'll go for 10 more seconds on this slide. If you need more definitions, we'll give them back after the lecture. Okay? 6 seconds. 3, 2, 1. All right. Tell me, identify this transformation. It says use arrow notation to describe the transformation. All right. Here we go. We got what? Reflection, rotation, and translation. Okay. First off, which one of these two, the blue or the red, which one is my pre-image? You think it's the blue, raise your hand. You think it's the red, raise your hand. Okay, it's the blue. The blue image is the pre-image. Okay, remember the pre-image just has capital letters. It is the original image that occurs. The red image is, well, the image. Okay, the image from pre-image to image. All right, if this is A, B, and C on the pre-image, this is A what? A prime, B prime, C prime, correct? All right, we got 3 particular transformations we've talked about. You got a reflection. Oh, come on. You got a reflection, a rotation, and a translation. Okay. Reflections, split, correct? Rotations, turn. Translations, slide. What occurred here? Very good. Rotated, correct? It rotated. I went from this point to this point. I simply turned. Okay, if you want to know, that is called a 90-degree rotation counterclockwise. Right? 90-degree rotation counterclockwise. Let me help us out here. 1, 2, 3, 4th row. Okay? Anytime I have a rotation, I need to start thinking in terms of my quadrants. Look how easy this is. If I start with point C and I rotate it counterclockwise, I'll go 1 quadrant to the left. If I started in quadrant 2, and I did a 90-degree counterclockwise rotation, I would go 1 quadrant down. Okay. How our rotations work. Clockwise, counterclockwise. Throughout class, we'll talk about more nuances in terms of how those work. Okay? Right, so this was a rotation. Next, tell me what happened. Y'all, please write it down. Think about it. Write it in your notes. What happened here? If you rotate, if you reflect, if you translate. Notice very carefully where my prime letters are located. Because otherwise you're going to fall into a trap that you don't want to fall into. The bad trap with spiky things and monsters. Mr. Hopper's web. All right. All right. How many people got translation here? Okay. What else did you get other than translation? Reflection. Got it. We go from DEFG, we reflect over what axis? X-axis. Very good. Okay. We reflected over the X-axis. Okay. And that is a flip or a reflection. Okay. Had this been DEFG, it would have done what? Translated or slid down, right? Okay. Everybody got me? This is a reflection over or about the X-axis. I think they'll always say over the X-axis for a reflection and about for a rotation. Okay? Get your phones out, please. Okay, let's see how we do here. Oh, come on, man. Stop. Oh, man. All right. Tell me what you get here. Reflection, rotation, or translation? No problem? Okay, that's okay. Right now, just write it in your notes then.
Yeah.
Okay. Yay! Way to go, Douglas. You're the man. What do you think it happened? What happened here? Yeah, move or slid, right? It slid right and down. Awesome. How about getting translation? That's what I'm looking for here, okay? All right. Good job. That's cool. All right. Now, everybody see that from our pre-image to our image, we moved or we slid from the right or to the right and then down, or we slid down and then to the right. Okay. If I put those letters as coordinate points, right? So -4, 6, correct? This is how a translation will be given to you. Translate this image 6 units to the right and 3 units down. Or translate the image 3 units down, 6 units to the right. Okay? That's what the wording will be in those particular, awesome, thank you guys, in those particular problems. Okay? All right. A little bit more for you to write down here. Isometry or isometry. I call it isometry. It's probably isometry. And potato. Okay. Transformation that does not change the shape or size of a figure. Reflections, translations, and rotations are all isometries. Isometries are also called congruence, transformations, or rigid motion. In your notes, you must include the words of the phrase rigid motion. Well, because in the standards, the state of Georgia, they include the phrase rigid motion. Okay? Let's see how we're doing. We've talked about 3 transformations today. What are they? Perfect. Which one of those 3 are isometries? Yes, all of them are. Okay? Very good. Very good. All right. Figures on the left are A. Figures on the right are B. Raise your hand if you think the figures on the left are part of isometry or isometry. Raise your hand. Raise your hand if you think figures on the right, figure B, are part of isometry. Okay. Raise your hand if you didn't raise your hand or you don't know. Right? If you raise your hand for A or for B, you're right. Both of those particular figures are part of isometry, right? Did the shape change from here to here? Did the size change from here to here? Did the shape change from here to here? Did the size change from here to here? Right? This was translated. This was reflected. Okay? Both of these are examples of isometry. Right? To give you 23 more seconds.
It's kind of weird.
20 seconds. No. 6 seconds. I'll come back to it if y'all need it later, okay? All right. You don't have to write this down, but this is where we're getting into the process of what we're going to do today. To define coordinates for the image of the figure and a translation. Notice this is just talking about translation. Add A to the x coordinate of the pre-image and add B to the y coordinate of the pre-image, yada, 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 yada. Okay? Right. There's a rule for this particular translation, for this particular transformation. I take a, let's just say 3, 4. Okay? I take that, that's image A. Sometimes today you're going to come across the word or phrase arrow notation. Arrow notation. An arrow. Okay? And I go to A prime. What do we call this? My pre-image. What do we call this? My image, right? And I want to translate this 2 units to the right and 2 units up. 2 units to the right and 2 units up. I will take my pre-image coordinate points, 3, 4, add 2 to each of them, and bibbidi bobbidi boop. Holy smokes, I've got my image. 2 units to the right, 2 units up. Not that hard. Some people get confused with this stuff, so I'll go over it. Let's say if I had those same points, 3, 4, and I moved it 4 units to the left, would I add or subtract? I'd subtract 4. So here we go. From 3, I'd go to 2, to 1, to 0, to -1, right? Correct? 3 minus 4 is -1. Okay? All right. That's really all we're doing in translation. So the easiest thing we come across. Okay? Real quick, write down for me, please, your pre-image coordinate points. for A, B, and C. All you have to write down is the coordinate points. In other words, what's A, what's B, what's C. Come across, get some volunteers, see what y'all got. What's A? -4, 2. Perfect. B. -3, 4. Let's see. -1, 1. Awesome. Don't have to reteach anything about the coordinate plane. Awesome. Everybody get that? A, B, and C. That's where we got to start, okay? Not too bad. Then I take each of those particular coordinate points. I'll add 2 to the x's, subtract 1 from the y's. Add 2, subtract 1. Add 2, subtract 1. This is my transformation. Okay? This is the transformation that is going to take place. Start with the pre-image. Pre-image. We include a transformation, which in this case is a translation. Then I get my A prime, B prime, C prime. Yay! Lucas, what's -4 plus 2? Perfect. Lucas, what's 2 minus 1? Okay. Fred, I'm just kidding. What's your name? Cheyenne, what is -3 plus 2? -1. I got this one. Okay, I'll let you come in there. 4 minus 1, 3. Okay. -1 plus 2. 1. I'll do this. 1 minus 1 is 0. Yep, positive. All right, now, I already drawn this for you. But if you go to -2, 1, -2, 1, you get A prime, -1, 3, you get B prime, 1, 0, you get C prime. So there's the translation, right? That's pretty much the substance of today's lesson. Over here, I get the image. Any questions on that? No? No? No, sir? Okay, sit here. Okay, that's all I got for today. Okay, I'm gonna give you your break.